Okay, so now our radians and degrees are filled up. How do I use these triangles to find these coordinates?
Well, right now our special right triangles, the hypotenuse is not 1
Not 1.
like it
Good.
needs to be.
That's the key ingredient to this little situation we have. This is a hypotenuse of 2, this has a hypotenuse of 2, and this has a hypotenuse of root 2. This hypotenuse, this triangle, has a hypotenuse of 1. That's a problem. So we need to convert all of these to a hypotenuse of 1. How do I do that?
You're going to divide each side by 2.
Divide by 2, 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 divide by 2?
Divide by 2.
No, not dividing 2 this time.
Divide by square root 2.
Root 2, root 2, root 2. Good. Okay. So this right here, if I were to make this a coordinate, and I'll say this one is 0, 0, then this coordinate would be over root 3 over 2 up 1/2. Okay, so if I use my circle, 30 degrees, remember 30 degrees, over root 3 over 2 up 1/2. So root 3 over 2, 1/2. What about that one? 45. I'll go over
1 over root 2 and up 1 over root 2.
Perfect. Over 1 over root 2, up 1 over root 2.
And do you usually rationalize the denominators on those, or do you leave that?
I could care less, but just so you know, that's the equivalent. Sometimes you'll see problems written like this,
Right.
and you just sort of have to know, I guess. But yeah, they're equivalent. So, and the last one? So this is over
a half and up root 3 over 2.
Notice that it's just switched. So 1/2 root 3 over 2. It's just switched, and that's literally because the triangle is switched. Okay? So now, we don't have to do that every time. There's some nice symmetry going on here. So how do I do this? This point is the exact same point as this. It's just the opposite x value. Same height, but the x value is negative. So it's negative 1/2. Same y value. Negative root 2 over 2. These coordinates are really small. Up root 2 over 2. Same y value. This and this have the same y value, but opposite x value. Negative root 3 over 2. Up 1/2. Same point, except opposite x value. See that? Same point, opposite x value. What about that one?
So that's the third quadrant. So we're going to have our x and y values are both going to be negative.
Good, but it's the same as this point.
Right.
Just flipped over there and then flipped down there. Okay, so it's this same coordinate. You can see that's also 30 degrees there. So what is the coordinate?
It's going to be negative root 3 over 2, negative 1/2.
Negative 1/2, good. All right, next one.
Negative root 2 over 2, negative root 2 over 2.
Okay.
Negative 1/2.
I think I didn't put a negative. Okay, negative 1/2.
And negative root 3 over 2.
Good. This one has same x values as this point, but opposite y value.
Okay. So we're looking at 1/2 and negative root 3 over 2.
Good.
And root 2 over 2, negative root 2 over 2.
Good.
And root 3 over 2, negative 1/2.
Perfect. That is your entire unit circle. You should be able to reproduce this in less than 2 minutes. I think that would be a good goal. Quiz yourself. It's very valuable. So how do we use this unit circle? What are some cases that we would need to use it? Well, let's take a step back. If you remember your right triangle trig, sine of theta, sine of the angle, is equal to what?
Well, if I remember correctly, it's SOHCAHTOA, which means sine is opposite over hypotenuse.
Opposite over hypotenuse. The hypotenuse is 1, right? And the opposite side you can see is the y value. 1/2 in this case. Which means that sine of theta is equal to y, the y value. Cosine is equal to adjacent over hypotenuse. So toa. That is equal to x, the x value. Divide the hypotenuse.
So √3/2 in that case.
Yeah, in this particular case. So this is x over 1, which is just x. Okay, so now I can ask you, Miss Yule, what's sine of pi over 4?
Well,
sine of pi over 4 is equal to the y.
So I'd have to go to the unit circle and look at pi over 4 and find the y value, which in this case is √2/2.
What's cosine of pi over 6?
Well, on the unit circle, the x value at pi over 6 is √3/2.
Good. √3/2. What's sine of 2 pi over 3?
Okay, so 2 pi over 3 is in that second quadrant, and I'm looking for the y value, so √3/2.
Good. So that's √3/2. Okay, so those are the sort of the forward examples. What about some more difficult examples? Let's try when, so sine of theta is equal to positive 1/2. When does that happen?
So I'd have to look at the unit circle and figure out where on the unit circle is the y value 1/2, which may occur in multiple places here. So we are looking at pi over 6.
Pi over 6 and 5 pi
5
over
pi
6.
over 6.
5 pi over 6, good. So, whoops, did I not write that? Theta equals pi over 6 and 5 pi over 6. Good. Okay, let's do one more. Cosine theta is equal to what's a good one?
Maybe
7?
a negative?
Yeah, there you go. So negative, no. I'm going to look here. Let's go 4 pi over 3. 4 pi over 3. Okay, so what angle produces a cosine? What angle produces an, oh, sorry, I did that wrong. Sorry. This needs to be a side length, so let's go negative √3/2. Okay, so what angle produces an x value of negative √3/2? So go to your unit circle.
So cosines are negative in the second and third quadrant. And I see a negative √3/2 at 5 pi over 6.
Good. 5 pi over 6. I'll use the green one. Seems more appropriate. 5 pi over 6 and?
And at 7 pi over 6.
7 pi over 6. Good. So now we have 5 pi over 6 and 7 pi over 6. I hope you get it. If you don't, ask Miss Yule. Thanks for listening.